When you flick a light switch, it feels like magic, a simple gesture that instantly fills a room with light. But have you ever wondered what really happens in that split second? The story behind that tiny click is far more complex and fascinating than it seems. That moment is actually the final step in an incredible journey that begins at a power station, which could be located hundreds of miles away from your home. These massive facilities are the beating heart of our electrical system, working around the clock to generate the energy we rely on every day. Power stations generate electricity in a variety of ways. Some harness the force of the wind with giant turbines. Others capture sunlight with vast fields of solar panels, and some tap into the Earth's natural heat through geothermal energy. However, most commonly, electricity is produced by burning fuel like coal, natural gas, or biomass to create steam. This steam spins enormous turbines, converting heat energy into electrical energy. The electricity produced at these stations is extremely powerful, far too much for our homes to handle directly, so it's sent out at a very high voltage, similar to how a high-pressure hose can send water a long distance without losing force. This high voltage is essential for efficient travel over vast distances. This electricity then travels through the national grid, a vast network of thick cables strung on tall pylons, stretching across fields, cities, and countryside. The grid acts like a superhighway for electricity, ensuring power can reach every corner of the country. These pylons are the motorways of the electrical world, moving electricity efficiently at up to 400,000 volts. Their towering structures are designed to carry huge amounts of energy safely and reliably, no matter the weather. If electricity traveled at the lower voltage we use at home, much of it would be lost as heat before it ever reached us. High voltage transmission minimizes these losses, making sure the energy stays strong on its journey. As the electricity gets closer to our towns and villages, it branches off the main motorways onto smaller cables. Here, transformers step down the voltage to safer levels, allowing the energy to flow into our neighborhoods and homes. This silent, invisible river of energy runs 24/7, powering everything from city skyscrapers to the smallest gadgets in your home. Whether it's your toaster, tablet, or TV, electricity is always ready and waiting, just a switch away. From giant turbines spinning in distant power stations to the cables and transformers right outside your window, it's a perfectly timed dance. Every second, this system works in harmony to deliver energy safely and reliably right to your street and into your life. The electricity you see traveling on those big pylons is incredibly powerful, far too much for our homes and everyday appliances to handle safely. These high-voltage lines are designed to carry electricity efficiently over long distances, but the voltage is much higher than what we can use directly. To make this electricity usable, it needs to be stepped down by special devices called transformers. These are essential pieces of equipment in the power distribution system. Transformers, which are often found in substations, work by reducing the voltage in several stages. The electricity might start at hundreds of thousands of volts, but transformers gradually bring it down to much safer levels, suitable for local distribution. The first major step in this process might drop the voltage to around 33,000 volts. This is still very high, but it's a crucial stage before the electricity can be sent closer to where people live and work. From there, the electricity travels along smaller, often underground cables that weave through our towns and neighborhoods. These cables are designed to be less obtrusive and safer for residential areas. As the electricity gets closer to your home, it passes through another transformer, usually housed in a green or grey box you might see on the street or mounted on a utility pole. This final transformer brings the voltage down to the standard 230 volts used in most homes in many countries. In North America, this last step reduces the voltage to 120 volts, which is the standard for household outlets there. This ensures that all your appliances and devices can operate safely. The last thick cable, known as the service cable, runs from the street transformer directly to your house. It connects to your electricity meter, which measures how much power you use. It's truly amazing to think that the energy flowing through that cable has traveled such a long journey, from a distant power station through the vast national grid and passed through several transformers before finally reaching your home. This careful, step-by-step process ensures that electricity arrives at your doorstep both safely and reliably, ready to power everything from your lights to your refrigerator. Every stage of this journey is carefully engineered for maximum safety and efficiency, with multiple safeguards in place to protect people and property. And that's how power makes its final approach to your home, completing an incredible journey that starts miles away and ends right at your front door. When electricity finally arrives at your home, it's delivered through three essential wires: live, neutral, and earth. These three wires form the backbone of your household electrical system, each playing a unique and crucial role in keeping your home both powered and safe. In the UK and Europe, these wires are easily identified by their color codes: brown for live, blue for neutral, and green with a yellow stripe for earth. This color coding isn't just for convenience, it's a vital safety feature that helps electricians and homeowners quickly recognize each wire's purpose, reducing the risk of dangerous mistakes. The live wire is the powerhouse, carrying a high voltage, typically 230 volts, straight from the grid into your home. It's this wire that delivers the energy needed to run everything from your lights and fridge to your phone charger. The neutral wire acts as the return path, completing the electrical circuit by carrying current back to the source after your appliances have used the energy. Without this return path, electricity simply couldn't flow. Remember, electricity always needs a complete loop to flow. The live wire brings the current in and the neutral wire takes it back out, forming a continuous circuit that powers your home safely and efficiently. The earth wire, on the other hand, is your home's built-in safety net. Under normal conditions, it doesn't carry any current. But if something goes wrong, like a fault or a short circuit, it steps in to protect you. By connecting the metal casing of appliances directly to the ground, the earth wire ensures that if a live wire ever touches the case, the electricity will flow harmlessly into the earth rather than through you. This simple connection can be the difference between a minor fault and a dangerous electric shock. Together, this trio of wires keeps your home not only powered but also protected, working silently behind the scenes every day. That's why strict color coding and wiring standards are enforced. They're absolutely crucial for everyone's safety, from professional electricians to everyday homeowners. Every single socket, switch and appliance in your home relies on this system to function safely and reliably, no matter how big or small. We'll explore just how vital the earth wire is in more detail a bit later, and why it's considered one of the most important safety features in any electrical installation. As electricity enters your house, it first meets the main fuse, also called the company fuse or service head. This sealed unit, owned by the electricity company, contains a strong fuse that protects the incoming cable and their equipment. If there's a major fault or surge, the fuse melts and cuts off all power, acting as the ultimate safety barrier. Next, the live and neutral wires go into your electricity meter. The meter measures exactly how much energy you use, so you're billed accurately. Modern meters are often digital or smart, sending readings automatically to your supplier. Electricity is measured in kilowatt hours, the energy used by a 1000 watt appliance running for 1 hour. Every device you use is counted by the meter, ensuring you only pay for what you use. It's a silent, precise witness to your home's energy use. After the meter, electricity passes through the main switch, or isolator, a big, easy-to-spot switch, often with a red background. This master control can instantly turn off all power to your house with a single flick. It's a double-pole switch, disconnecting both live and neutral wires for complete safety. Electricians use it to safely work on your wiring, but it's also there for emergencies like fire or flooding. Everyone in your home should know where the main switch is and how to use it. It stands guard between the meter and the rest of your home, like a main water valve for electricity. If there's a major problem, this is the switch to use. It's a simple device, but its role in your home's safety is massive. The isolator is your ultimate control over household power. After the isolator, electricity arrives at the consumer unit, also known as the fuse box. Here, the main supply is split into smaller circuits for different parts of your house, like lights, sockets, and high-power appliances. Inside, metal bus bars distribute power to each circuit, while all earth wires connect to a single earth bus bar for safety. This separation means if one circuit trips, the rest of your house stays powered. Each circuit is protected by its own safety device. The consumer unit is the central hub managing and protecting all your home's electrical pathways. Modern units are packed with safety technology, quietly keeping everything running smoothly. Inside the consumer unit, you'll find rows of switches, modern replacements for old fuses. The first type is the MCB, or miniature circuit breaker, which protects each circuit from overloads and short circuits by tripping if there's a problem. If you plug too many powerful devices into one circuit, the MCB trips to prevent overheating and fire. The second type is the RCD, or residual current device, which protects you from electric shocks. It constantly compares the current going out and coming back. If there's a difference, it trips instantly, cutting the power. RCDs can detect even tiny leaks of current, acting much faster than MCBs. Some consumer units use RCBOs, which combine both functions for individual circuits. These devices are lifesavers and are standard in modern homes. Together, they keep your wiring and you safe. Now, electricity travels through your home circuits to power sockets and lights. In a typical socket circuit, cables form a loop from the consumer unit, connecting each socket in turn. Plugging in an appliance completes the circuit, letting electricity flow from live to neutral, powering your device. The earth wire connects metal casings to ground, providing a safe path if a fault occurs. If a live wire touches a metal case, the earth wire carries the current away and the MCB or RCD trips instantly. Lighting circuits work similarly but use thinner cables since lights need less power. The wall switch simply opens or closes the live connection to the light fitting. Flick the switch on and electricity flows to the bulb. Flick it off and the flow stops. Every switch and socket is part of these carefully designed, protected circuits. That's how your home stays powered and safe. Every part of your home's electrical system is designed for safety, from transformers to trip switches. The earth wire is the most important safety feature, providing a safe escape route for fault currents. Understanding how electricity travels helps us respect its power and its dangers. Never attempt electrical work unless you're qualified. Leave it to professionals. Simple tips. Never use damaged cables, don't overload extension leads, and keep water away from sockets. If a circuit breaker trips, reset it once. If it trips again, unplug devices or call an electrician. Next time you switch on a light, remember the incredible journey electricity has taken to reach you. Knowing how it works is the first step to using it wisely and safely every day.